Myself, Hariharan, and my roll number is 22Z222, and I'm here to give introduction on GitHub Copilot. What is GitHub Copilot? It is an AI-powered coding assistant developed by GitHub, OpenAI, and Microsoft. It uses OpenAI's Codex model built on GPT architecture to suggest entire lines, functions, and even algorithms. It integrates into IDEs like VS Code, JetBrains, and NeoVim to assist developers in real time. Now, let's see why it is important. It speeds up coding by suggesting relevant code snippets. It reduces cognitive load, allowing developers to focus on problem solving. It enhances learning by providing contextual recommendations and alternative approaches. Now, let's see the evolution of AI driven coding tools. The early days, basic code autocomplete. IDEs like Eclipse and IntelliJ introduce simple syntax based suggestions, static code analysis. Tools like ESLint and PyLint help detect errors but lack deep learning capabilities. Machine learning in coding. AI-powered autocomplete. Early ML models like Tab9 and Kite provided smarter code suggestions. Pattern recognition. AI started understanding coding structures but still relied heavily on predefined rules. The deep learning revolution, 2020 to present. Transformer-based models. The rise of GPT-like models enabled AI to understand code semantics, not just syntax. GitHub Copilot launched 2021. First, mainstream AI that writes, completes, and explains code based on natural language prompts. Continuous learning. Copilot improves on based on user feedback, making it smarter over time. Now let's see why GitHub Copilot is a breakthrough. AI-powered code generation. It generates entire functions, not just single line suggestions based on context. It understands natural language and converts comments and descriptions into working code. Adaptive learning and context awareness. It learns from previous lines of code, recognizing patterns and coding style. Seamless IDE integration. Works smoothly with VS Code, JetBrains, and other popular development environments.
My role number is 22 Let's see the purpose, scope, and limitations of GitHub Copilot. Let's see the core objectives. First is accelerated development. It significantly reduces boilerplate code writing and increased developers' velocity. Contextual suggestions. Its ability to understand the context of the code being written, providing relevant suggestions based on function names, commands, etc. Reduce cognitive load. It aims to minimize the effort required for repetitive tasks, allowing developers to focus on high-level problem solving. Exploration and learning. Uh, it helps in assist in exploring new APIs, libraries, and programming patterns, especially for developers working in unfamiliar languages. Next is problem-solving approach. Pattern recognition. It leverages machine learning to recognize patterns in vast amount of public code. Probabilistic suggestions. It generates code based on probability, not deterministic logic. Contextual inference. It analyzes the surrounding code, commands, and structures to generate contextually relevant suggestions. Iterative refinement. The developers can accept, reject, or modify suggestions, contributing to an iterative development process. Let's see the capabilities and limitations of Copilot. Let's see capabilities. To generate boilerplate code, automate the creation of repetitive code such as loops, structures, conditional statements, and functions, such as function implementation. Provide potential implementation based on function signatures and commits. Offer code completions, such as the next line or block of code. Generate unit test. Create basic unit test based on the existing code. Assist with API usage. Provide example and usage patterns for different APIs and libraries. Translate between languages. Basic translations can be performed. Let's see the disadvantages. Guaranteed correctness. Suggestions are all not always accurate or optimal. Developers must review or test the generated code. Replace human's judgment. Copilot cannot replace the need for critical thinking, problem solving, and architectural design. Understand complex business logic. It may struggle with highly specific or intricate business requirements that are not well represented in training data. Handle all programming languages frameworks equally. It supports many languages. Its performance may vary depending on the availability of training data. Ensure code security. It generates code with security vulnerabilities, create novel algorithms. It is better at replacing existing code rather than creating brand new algorithms.
Hello everyone, my name is Jayavarshini and my roll number is 220227. Today I am here to discuss on the topic of AML behind the GitHub Copilot. So first let us discuss why GitHub Copilot is an AML product. Basically GitHub Copilot is not just an autocomplete tool, it is a machine learning based AI model. So the core of Copilot is OpenAI Codex, which is a deep learning model trained on billions of lines of publicly available codes. So this follows and allows to understand and generate code across multiple programming languages like C, Java, C++, Python, etc. So Copilot doesn't just recognize the codes, it also interprets plain English commands and translates them into working code, making it an AI assistant for developers. So it adapts to the developer's coding style by analyzing the past interactions of the developer, so making its own suggestions and more personalized and customizable. So unlike a basic autocompile, Copilot understands the logic of a function and predicts the entire line or even a full function, enhancing the developer's productivity. So basically, GitHub Copilot is an AML product because it continuously learns from massive dataset, understands human-like instructions, and also evolves based on the user feedback. Yeah, this is basically a small diagram where the GitHub Copilot server acts as a bridge between the codex model and the developer's code editor. It processes the context from the editor and generates intelligent code suggestions back to the editor. So the key functions are, the first one is provider edited context. So Copilot understands the developer's current code in comments and also the surrounding environment in the code editor. And it also, based upon the context, it also generates accurate and relevant code suggestions. So basically with the continuous refines, it refines of its recommendations based on the user edits and feedbacks. So basically private code integration works within VS Code or any other IDEs where assisting with private projects while respecting data privacy. See, this is just a small timeline. So this timeline showcases the journey of fundamental AI research to an intelligent coding assistant, making software development faster, smarter, and more efficient. So GitHub Copilot is the result of continuous advancement in the AI-driven code generation, involving from early deep learning models to a specialized developer tool. Yeah, now let us discuss each one of the concept. The first one, transformer models. Basically, what are they? Transformers are neural network architecture introduced in 2017, which revolutionized the NPL by using attention mechanism to process all the words in the sequence simultaneously. So basically the working of transformer will be like they use attention to weigh the importance of different words in relation to each other, process these sequence in parallel rather than one token at a time, so handle long range dependencies in the text. So basically there are some of the components in the transformer model. The first one is encoder. So break down the input sequence into meaningful representation, understands the code structure, variables, and also relationship and context. Positional encodings. So they capture the location of each token in the sequence, so which is essential for understanding the code syntax and also the order of the sentences. Decoders. They generate the output based on the learned representation, which is used for predicting the next lines of code, completing the functions, and even suggesting some of the improvements in the output. Softmax layer. So softmax layer determines the most probable next token that can either be a word or a code snippet. So helps Copilot rank and refine suggestions based upon the relevance. So here we can see an example where def calculate average is a function which takes numbers as a parameter and it calculates total. But this function is not yet completed. So basically transformer can look at all the tokens simultaneously, understanding that the variable token in the function called calculate average with the parameter numbers. We likely need to sum up the numbers, so it doesn't process one word at a time but it considers the entire text. Now let us move on to GPT-3. So what is GPT-3? Generative Pre-trained Transformer 3 is a massive scaling up transformer architecture with 175 billion parameters trained on vast amount of internet text. So the key components of GPT-3 are multi-layer transformer, feed-forward and normalization layers, positional encodings. Processes input sequentially, understanding context, and the feed-forward and normalization layer basically improve the learning efficiency and the output accuracy. Positional encoding helps maintain word or a token order in the sentences as we discussed earlier. Similarly, this positional encoding is also in the transformer model. So how GPT-3 handles different tasks? Basically, there are classification, entailment, similarity matching, multiple choice, and context handling. So classification is nothing but identifies categories in the text, which can either be yes or no. Entailment determines one statement logically follows the other. Similarity matching finds the relationship between different pieces of text or code. Multiple choices and context handling is nothing but which helps in question answering and decision making tasks. As we discussed earlier in the transformer model, GPT-3 can generate this complete code because it seems millions of similar patterns in its training data. So that basically this code was that optimized, but this code works perfectly. Now open code AX, so which is the main building block of GitHub Copilot. So GPT-3 model specifically fine-tuned on billions of lines of public code from the GitHub repository. So basically a ChatGPT model specifically fine-tuned on billions of lines of public code from the GitHub repositories. How it works? So basically started with GPT architecture and parameters. Further, this OpenAI codex is trained on with multiple programming languages like Python, JavaScript, C, C++, etc., which is optimized to understand the code context, documentation, and also programming patterns. So better understanding of programming languages, syntax, and semantics helps us the OpenAI codex to provide the perfect code whenever the user or the developer tries or provides a comment. Here we can see an example. So we have a function def factorial. Before the function I have provided a command line which is calculate the factorial of a number using recursion. Basically the OpenCode AX can observe the environment and also the command statements in the IDEs. So basically it provides the entire code. So codex understand the programming concepts like recursion and can implement them correctly based on just a command. So these are the main building blocks of GitHub Copilot, which are transformers, GPT-3 and OpenAI codex. Further topics will be discussed by my teammate.
So myself Hemant, and I will be discussing about the technical workflow of GitHub Copilot. So first, the workflows in GitHub Copilot is separated into 6 parts, and these 6 parts will be clearly defined in this flowchart. So basically, the GitHub Copilot works in a sequential pipeline manner. So the first thing, it starts from the code editor, and then the input is converted into a prompt, and then this prompt is filtered using proxy filters, and then it is sent to the OpenAI models via codex, and finally the response is fetched from the OpenAI models and returned to the code editor where the client asks for the code, and then this code, depending upon the response from user, either accept or reject, it gathers the feedback and it loops into a feedback loop where it is a continuous learning environment, and this history is retained to the data centers to maintain the accuracy of the AI models. First is the input and prompt processing. So the input and prompt processing generally deals with the input processing. So basically it gathers the input from the user, like here for example, if the user asks about tell me about space, or let's go into a coding context. So let's say write a Fibonacci program in Python. So this is the prompt of the user. The first step is basically like every NLP models, it tokenizes the user prompt and then it processes for the AI model. Second is the proxy and content filtering. So before sending the prompt to the codex, it has to do some filterings, which like it includes the validation of code context and blocking malicious keywords like the open API keys or passwords. So let's say here we have an example. This is the before filtering example. So let's say a user has the constant password is equal to 123456 and he has some API key. So before sending this request to the AI model, it has to eliminate this by either placing a placeholder like password is equal to your password and API key is equal to your API key. So this is called as proxy filtering, and after proxy filtering, this sanitized input is sent to the OpenAI model, and then the raw AI output is again filtered using content filtering. So this content filtering mainly deals with some code correctness validations, and it removes hard-coded credentials like weak encryptions is blocked. So this final filtered output is sent to the user. Analysis and code generation. So let's say I have asked the GitHub Copilot itself to show me the sample request and the sample response. So the sample request generally deals with like the original natural language prompt that the user has sent. In my case, I have sent like create a simple tic-tac-toe game using Python. So this is my natural language prompt, and then this prompt is received along with an empty file test.py. So after receiving these inputs, the GitHub Copilot directly writes the code for tic-tac-toe program using Python in test.py, and that is my response. And then it also deals with user interaction editor. So after receiving the code, we have another option in GitHub Copilot like inline editors. So if we select all and click I, control plus I, it shows an inline block. Here we can ask the Copilot to do whatever we need. So I have asked the Copilot to modify the same code to two AI playing against each other intelligently. So before this prompt, the code is like the code deals with the play deals with playing tic-tac-toe between two users normally. But after this, when I click accept here, it will change into two AI playing code. So this is an example of user interaction in editor. And then finally the feedback loop. So every NLP model and LLMs has some kind of feedback. So here in GitHub Copilot, the first step is the user interaction in editor, and then second step is the capturing of response from the user interaction, and after this capture, it deals with data collection, and finally this data collection leads to the model improvement and deployment. And after deploying, the AI weights will be updated to adapt to the user's request, and the improved suggestions will be shown to the user. And then this GitHub Copilot is in a continuous learning environment. Unlike static tools, with every update, this Copilot becomes more intelligent, accurate, and versatile. So basically this is how the continuous learning environment works. First is the user interaction, and then from the user interaction, the feedback is collected and sent to the data center, and from there, using historical learning, the AI model is fine-tuned and then deployed again. So this deployed fine-tuned model is again used by the user interaction, and this is how the continuous learning environment works. Thank you.
Myself Jeevashakthi, roll number 226228, and I'll be explaining about system architecture and how its A model powered by transformer-based deep learning generates intelligent code suggestions. GitHub Copilot follows three-layer architecture and ensures real-time AI-assisted coding. These layers can include client-side ID execution, backend services, AI model. So each of these layers ensures efficiency, security, and responsiveness. We see them in the following slides. So the first one is client-side architecture. So the IDE extension acts as an interface between developer and Copilot. So it performs four key operations. The first one is capturing user context. So it tracks the active file that we are currently working on, the current function, the imports, the syntax, and the current position of the cursor. This is to determine the complete relevance, which part of the code we are working on, and recent code edits to improve the accuracy of the code that is generated. Next is the pre-processing input. It extracts relevant code and prepares the structured API request. Then secure transmission sends the request using scripted HTTPs or WebSocket protocols. And finally, we have rendering AI suggestion, which displays the AI generated code inline, which allows the users to accept, modify, or reject it. So this setup ensures that the AI model receives well-structured input for generating meaningful suggestions. So once the API request is sent, the request goes to the backend of the system. So we see what happens in the backend system and API, how the API is processed. So backend system and API processing pipeline. So once the ID sends the request, the backend refines before forwarding to the AI model. So there are four key stages here. First one is the API gateway. It manages authentication, request validation, and rate limiting. So next is pre-processing engine. So it structures the input code and it's also responsible for detecting what programming language is used. And finally, and third, we have Codex Model Server. So this is considered to be the heart of the GitHub Copilot. So it uses deep learning transformers to generate multiple code completions. And finally, we have post-processing security filtering. So it's nothing but we'll be removing the insecure copyrighted bias suggestions once the code is generated. So this pipeline ensures secure, structured, and optimized input for AI models. So next, at the heart of the GitHub Copilot is OpenAI Codex. It's a transformer-based model trained to understand and generate code. So how a codex processes the request? First, the request is broken down into tokens and it's tokenized into small units. These tokens are converted into numerical vectors. So next we have transformer-based code understanding. So we have something called self-attention mechanism. Self-attention mechanism is nothing but we are going to focus on the relevant parts of the code and leave out the irrelevant parts of the code. So we have multiple head attention layers which allow these codecs to understand how the function structures, the variable dependencies among the program and programming logics. So third, we have auto-regressive code generation. Auto-regressive code generation is nothing but we have multiple code generated in aggressive manner. So they'll be predicting the next tokens that is to be generated based on the input context. So finally, we have something called confidence score. So when the confidence score is high, we'll be selecting that particular code. So next we have post-processing and tracking. Post-processing and tracking is nothing but once the code is generated, we need to ensure that code is syntactically correct. If it comes in the best programming practices and it is similar to the user, how the user writes and the code and so on. And finally, we have response packaging and delivery. It's nothing but the highest rank is selected and it's compressed and sent back to the API gateway. So as we've seen earlier, before sending a response, Copilot applies several security and compliance measures. The first one is license compliance check, which ensures that the generated code does not violate copyrighted snippets, and bias and ethical screening. It filters the bias, harmful, and unsecured code generations, and it also prevents AI manipulation and it ensures reliability. So these steps help maintain ethical and secure AI-driven coding. Finally, the highest rank suggestion is sent back to the IDE by compressing it, sending back to the IDE. So the extension now displays this AI generated suggestion in line. So the user interacts and helps refine the future model updates. So this feedback will continuously improve the Copilot's accuracy and efficiency. Now let's see about transformer based architecture with an example. So this is a transformer based architecture as we seen earlier. So we have an encoder and a decoder. So first our input sequence is tokenized and it's embedded into key value and query. So these key value and query are used to find the attention score which we were talking about earlier. So now the attention score is generated and we have multi-head at self-attention. So here it is again, it is given as output. From here we can decode it and the output will be fed as an input to decode it. Now let's see this in detail. Tokenization. For example, as we seen earlier, when the developer types the code in the IDE, it's split into tokens and tokens are converted to vectors. For example, here in the definition, in this line, def calculate area radius, each keyword is tokenized, def calculate area radius and so on, and each vector is now mapped in a high dimensional vector. And next comes the Push encoding. Push encoding is nothing but in Transformer we don't have a concept where it understands the sequence of order cannot be understood like neural networks. So in order to retain that information, Copilot adds positional encoding. It's nothing but we need to know the relative position of the function call, loops and conditions and assignment operations in the program. So we use positional encoding. Positional encoding comes as a sine and cos wave. So it's nothing but it's given as P positional encoding position 2i is equal to sine of position by 10,000 power 2i by t, where POS is equal to position of the token in this particular sequence, I is the embedding index and D is the embedding dimension. So here we have given input, we have tokenized, we have embedded, positional encoding is done. Now we'll find the attention score and we give this is in a feed forward neural network, and finally the output before the output is taken, we use the softmax function, and the output is taken. Using confidence score, we select the best code. So multi-head self-attention mechanism. So this is one of the most important aspect of the transform model is self-attention. So each token in the input attends to every other token, which assigns different ways based on the relevance. So self-attention enables Copilot to recognize patterns like variable dependency, function call, definition, scope, in relationship, in groups and conditions. So the attention score is computed using the formula attention QK V is equal to softmax of QK power T divided by root of TK into V. So here Q is query, K is key, and V is value are the transformation of the token embeddings that we have done in the first step itself. And finally, we did softmax function which determines the attention base, and V is nothing but scaling factor. So for example, we have a function called definition add AB return A plus B. The attention mechanism ensures that A and B are strongly likely to return statement. So Copilot uses multi-head attention where multiple self-attention layers run in parallel, each capturing different aspects of the code, which one about syntax, one other about semantics, and so on. So this output are passed through fully connected feed-forward network. So this goes every layer by layer, and these layers are normalized. So after normalization, it becomes stabilized, so it prevents large weight updates. And finally, we have decoder. So as we seen earlier, Copilot follows auto-regressive decoding. So it generates code token by token. So previous token are taken as input, it predicts the next likely token, and it repeats until the complete code snippet is formed. For example, we have a code def calculate area radius. So here model might predict return 3.4 into radius into radius. So the decoding uses top case sampling or top peak sampling to generate meaningful suggestions.
Hello everyone, I am Kabhinyasri. My roll number is 22Z229. Now let us see about the performance evaluation and edge cases in GitHub Copilot. Let us see how the performance varies across different languages. GitHub Copilot is trained on a massive dataset of publicly available code. So there is a chance for performance variation among different languages. So compared to other languages, the Copilot works well with Python, JavaScript, C++, etc. because of these languages are widely used. So it can easily generate React components in JavaScript, and in Python it can easily generate the data processing functions. But in languages like Go and Rust, it struggles with the advanced and less common features. It also adapts to commonly used syntax and patterns in React, Django, Spring-like languages. But when it comes to assembly languages, which is a low-level programming language, the Copilot suggestions are inaccurate because of the less training data. Now let us see how the Copilot handles simple and complex tasks. In simple tasks, the Copilot is excellent in handling the boilerplate codes, basic algorithms like sorting, recursion, and repetitive code snippets like API requests and database queries. So when we ask to generate a Fibonacci series, it can easily provide a code. When it comes to complex applications like AI model implementations, the Copilot lead to some failure. This is due to the long-term dependencies that exist between the files, so the Copilot struggles for large-scale projects. So when a simple task of writing, reversing a string provides a high accuracy, whereas implementing a compiler optimization algorithms fail to deliver the correct logic. So handling the edge cases, the common failures which exist in the programming languages is that it struggles with the null cases and floating point precision errors. So for example, when generating a binary search function, it assumes as a sorted array, but the input may be unsorted array. So this leads to a failure. And it fails to handle the loop conditions, and it may lead to the infinite loops. So the reasons for these edge case failures are that AI models like Copilot are trained on the patterns from existing code, so it cannot think and act like a human being. Thus, there is no runtime validation, and it does not have any awareness of how to handle the logic inconsistencies.
So there are ways for optimizing the GitHub Copilot's performance. So we can improve the performance by providing clear function names and meaningful comments. So the GitHub Copilot can be best used for repetitive tasks and boilerplate codes, so which can be easily generated and get better accuracy. But it cannot be used for security sensitive applications. So the improvement can be making them work for better optimized solutions and project-wide context. So the OpenAI and GitHub are currently working on improving its ability. Thank you.
Hi everyone, I am Gokul. I am from BCCG1. Today I am discuss about GitHub Copilot versus competing AI code assistants. First, we saw about what are the AI code assistants and a comparative analysis about that. The AI-powered coding assistants improve productivity and reduce manual effort. This In this presentation, we compare GitHub Copilot with Amazon Code Whispers and Tab 9. The key aspects of this presentation is features, and strengths, weakness, and best use cases of those AI code assistants, which we saw about that. Next, we saw about feature comparison. The features of those GitHub Copilots and any other code assistants. AI features like AI model, languages, cloud versus local, ID support, pricing. First, we saw about GitHub Copilot. OpenAI Codex is a AI model. Languages is support multiple languages, Python, JS, C++, etc. And cloud versus local, it basically used a cloud-based platform. GitHub Copilot is a cloud-based platform. ID support, it support VS Code, JetBrains, NeoVim, and the pricing is paid, and it's also free for student has also freely accessible for GitHub Copilot. And next we saw about Amazon Code Whisperer. And in AI model, it uses AWS ML model. In languages, it uses multiple languages like Python, Java, etc. Uh, in the storage unit, it uses cloud-based storage like GitHub Copilot. In IDE support, it uses VS Code and JetBrains. Pricing, it has also free tier, plus it also has AWS Pro, which is included with AWS Cloud Platform, which we subscribe by AWS. It also uses for this code assistance. Next, we saw about Tab 9. The AI model for Tab 9 is deep learning and rule based. The languages which used is many languages in which deep learning is only limited, and the storage of is hybrid, which is both cloud and local based platform storage platform. In IDA support, it uses VS Code and JetBrains. Pricing, it's also free and paid. The free has giving a limited versions of that code assistance. Next, we saw about what are the strength, weakness, and best choice for each of the code assistants. First, we saw about GitHub Copilot. In GitHub Copilot, it's best for multi-language support, full code generation, and smart suggestion in a GitHub. And also in a VS Code, the weakness of the GitHub Copilot is it's expensive and sometimes generate incorrect or insecure code. It is a weakness for the GitHub Copilot. Mostly best for a multi-language support and code generations easily. The Amazon Code Whisperer is a best for ideal for AWS developer with security scanning features. The Amazon AWS developers can easily accessible with Amazon Code Whisperer, and the weakness of the this code assistant is not as powerful outside the AWS ecosystem. It's not effective in the outside of AWS ecosystem. And the tab 9, it's a strength of the tab 9 is best for privacy conscious developers with local AI models. And the weaker in the tab 9 is its multi-line code generation is comparatively lower than Copilot. The Copilot is comparatively better than these two of them. Thank you.
So I'll be explaining about the ethical, legal and security challenges in AI code assistance. Myself, Harshini SP, roll number 22Z224. So before we get into the actual content, AI-powered code assistants such as GitHub Copilot, OpenAI Codex, they have significantly transformed the way developers write code. So, however, along with the code that is generated from these, they also introduce ethical, legal, and security challenges. So, we'll be explaining about the risk of AI-generated insecure code, copyright and licensing issues, and user privacy concerns. So to start with, we have the risks of AI-generated insecure code. So when we look at the vulnerability aspect, although AI gives a lot of code that has been requested by the user, the user does not verify whether this code is correct, and they may actually use the code without verifying it. So what vulnerabilities might it have? So the first one is SQL injection attack. So the AI may suggest database queries without proper user input, and these queries may fetch data from the database, leading to manipulation or even stealing. And next is the cross-site scripting, that is XSS. So if the user input is not properly sanitized, the hackers can actually inject scripts that run in the victim's browser, stealing cookies or even login credentials. And next is the weak authentication method. So the authentication method that we have nowadays, like multi-factor authentication, may not be present in the AI, making the accounts more vulnerable to attacks. And next is the propagation of legacy issues. So we have the use of deprecated cryptographic functions, meaning it may use old encryption algorithms which may be easily broken and decrypted. So next we have the insecure random number generation. So which actually how it works is it generates a random number and it's used for encryption. But AI may actually guess this random number, and attackers may predict this random number and they may invade into the user's data. So this will compromise security and lead to malware attacks. Next is the bias amplification. So we look at the bias in the code, comments, and documentation. So AI may generate comments that reinforce stereotypes found in the existing datasets. And next is programming bias. So AI may favor certain languages based on the data it was actually trained on, and hence it may push all the other languages to the side. And next is uneven quality across languages. So this is actually similar to the bias that we've already talked about. So let's say it is well trained on Python and JavaScript, and the code and the content that is generated based on these languages may be of higher quality than the other languages. This may lead to inconsistencies. And next is the false security. So we have an important term called security through obscurity. So AI may generate code that hides sensitive data rather than properly securing it. So it basically hides the data, then securing it. So hiding is not a substitute for like a strong security, right? Because security involves encryption and authentication, whereas hiding does not. And next is the over-reliance on AI suggestions. So if developers, they blindly depend on AI generated security mechanisms without actually validating them, they may of course introduce vulnerabilities. And next is the untested implementation patterns. So although the AI generated code is syntactically correct, it can actually have a lot of functional problems. Because this code is not properly tested by the AI. So let's say there is a particular algorithm and the edge cases are not considered. That is, it is not properly tested for all the possible inputs, leading to crashes or unexpected behavior. And next is concurrency issues. So it may lead to race conditions. And next is the resource constraints are ignored. So considering the existing resources, how it can be implemented, that may be ignored. And next is the copyright and licensing issues. So the question, does Copilot violate IP laws? IP here, it means intellectual property. So actually we had a GitHub Copilot controversy that is they actually were charged of class action lawsuit, alleging that Copilot violated copyright laws. So the main argument was that the generated code, it actually resembles the existing code that was provided by the user. Of course, this shows that the licensing has been violated. And the counter argument was that it did not copy the code. Instead, it generated new content based on the learned patterns. So next is the license compliance challenge. So the open source licenses dictate how code can be used. However, AI assistants struggle to reinforce these requirements. And next is the fair use defense. So some argue that training AI on open source code, it falls under the fair use, but the AI generated code, it should be different from the original, considering the copyright that has been issued. However, Copilot generates nearly identical to the existing code. Next is the legal developments. So in 2024, again, when the lawsuit was charged like against the GitHub Copilot, the federal judge dismissed, and but like further problems related to Copilot may be put up, but this particular problem was dismissed by the federal judge. And international regulatory differences basically mean that different countries have different rules, so it is pretty difficult to follow a particular rule related to this AI. And next we have how OpenAI and GitHub handle user privacy concerns. So data collection, both companies, they collect user interactions, improve their models, and raise questions about what code is recorded and how long it is kept. So mitigation approaches involved GitHub's legal protection, meaning it offers legal responsibilities, and it basically agrees to face lawsuits due to Copilot generated code. And next is the opt-out options. Users choose to exclude their private repository from AI training. And OpenAI's security checks perform scans to detect malicious prompts and prevent AI from generating harmful code. Next is limiting harmful code generation. So the ongoing challenges that we have right now is the lack of transparency and the difference between inspired by and copied from, because we never know if it's inspired or copied. And next is the potential for data extraction attacks. So sensitive data may be extracted, so that is still an ongoing challenge. And next is global compliance issue, meaning different countries and different regions have different AI generated content that must comply with these laws.
Hi everyone, I am Harish and my roll number is 22 is at 223, and I will be discussing on the topic future of AI in software development. And first of all, let us see how AI changes the role of developers in software development. AI assisted coding has already started changing how developers have to work. Tools like GitHub Copilot are making coding more efficient, but this is just a beginning, and AI is evolving rapidly, and in the near future it will do much more than we all think of. Next generation AI tools will offer better contextual awareness, error detection, and domain specific optimization. And next we will see about how AI's role in software development will be changing from on 5 to 10 years. And some of the key predictions include advanced code understanding. Future AI does not just generate the code what we need, it also understands the entire project and also helps to recognize design patterns and suggest some structural improvement. AI driven autonomous debugging. Future AI tools will automatically detect, fix, and explain the errors. And since debugging is one of the most time consuming tasks in developer, AI assistant debugging will reduce time spent on debugging and fixing and troubleshooting. And next, context aware code generation. AI will analyze the entire code bases rather than just local snippet. And future AI models will analyze entire repositories, ensuring that suggestion will fit in the overall architecture. And next, AI in low code or no code development. AI-powered low-code or no-code platform will enable even non-programmers to build application using natural language description. That means even if without a prior coding knowledge, they can develop a code using AI by using the natural language as a prompt. And next we'll see about AI's impact on developer roles and workflow. First of all, it will be boosting in productivity. AI will handle repetitive coding, allow developers will focus on complex logic and architecture and further innovation in the project. Shift in developer roles. Instead of writing every line of code, we can just supervise the AI code and test it and refine the AI code further. Ethical and security consideration. Although AI provides the code that we needed, there may be a chance of some bias, some errors, and some security flaws. Future regulation will ensure strict AI governance in software development. And next we will be discussing on, will AI replace developers? And my simple answer will be no. AI lacks creativity, reasoning, and problem solving skill that human have. AI will just generate codes by using the prompt that you are giving. So AI lacks true reasoning and deep problem solving skills. AI as an enhancement tool. AI will serve as an assistant handling routine coding while developers focus on architecture, logic, creativity. And AI tools will remain as assistant handling repetitive tasks. And finally, we will see about the conclusion that we have seen so far. GitHub Copilot is a game changing, but it's just an beginning. AI assisted coding will continue to evolve, and AI will developers must adapt to AI driven workflow to stay competitive. However, AI alone isn't enough. Human oversight is essential to ensure quality, security, and ethical coding practices. AI won't replace developers, but will define software engineering. Thank you.